already a critical mass, Andrea. I would, even if we have more registrations, I would suggest to start so that people then can
Will you,
come in.
you introduce, right, Gaby?
Absolutely.
You go first.
Super great pleasure. Hello, everybody. While others still come in, I would love to start today's meeting already because there is so much to say, and we have somebody who can speak so well, actually, also, Andrea. It's such a pleasure to listen to you when you speak, and is so well informed and expert that I think it's good to give us more time. What we're doing today is, in a way, from our perspective of our research area, knowledge governance transformation, a special treat for us for the pre-closure phase. We're talking about something that is also our research focus, quantification and the role of statistics in politics. And we do that as the final event of our event series in the cluster on experts, knowledge and authority in politics and decision-making. Just a short disclaimer, at the beginning of the next academic year, we will send again a call for expression of interest, but if any one of you wants to present their research in the next academic year, please make sure to contact us, and we will find a date for you to present to our cluster participants. We are here today to discuss a book that was published last year on the politics of modeling, numbers between science and policy. That's edited by Andrea Saltelli and Monica Di Fiore, and lies at the intersection of modeling, quantification, governance, and decision-making, and with that has many implications on what we're doing in research, but also what ethical concerns, what regards ethical concerns, governance questions of political authority, and with that it touches upon many areas as a book. First of all, obviously mathematical modeling, but also political authority, complexity, agnotology in policymaking, the questions of evidence-informed policymaking, and what Andrea himself frames as the power of invisible numbers in policymaking, which are very important and potentially a huge problem. Thematically, the book circles around climate change and COVID, and I'm happy to see many participants who work on both policy areas. We are here today with one of the editors of the book, with Andrea Saltelli. Andrea has a doctorate in chemistry and himself a very multidisciplinary background. He works on environmental science, on science for policy, impact assessments, on questions of applied statistics, obviously, and has a background both in science advice for a long time, and research himself. From 2005 to 15, he worked towards the end then as head of unit of econometrics and applied statistics in the JRC in ISPRA, and he also holds academic positions with the University Pompeu Fabra at the Barcelona School of Management, and with the University of Bergen and the Italian National Research Council. The main disciplinary focus, I guess, fair to say, at the moment is sensitivity analysis and sensitivity auditing, but you also have a strong focus on science reproducibility, apologies for that, and science integrity, also ethical questions of quantification. We talked about that just before you all joined. And with your research and the book especially, you bridge the perspective on statistics, quantification in politics, governance, and the impact of the subsystems on each other in a very, very informed and academically saturated way that is, however, extremely accessible for people who are also not necessarily data scientists. And Andrea, as I said, I'm personally very, very happy because I always love to listen to you, and I'm very much looking forward to your presentation. We said 45 minutes roundabout, you present your ideas and books, and then we are entering into discussion. Over to you. Thank you very much for being here.
Okay, thank you. Thank you, Gaby. Okay, so we can now start this presentation. In case you want to take some of the reading suggestions I offer, you can find a copy of this presentation already on my website, which is very easy to find. It's just a website with my name, and under resources you will find a PDF copy of this presentation. But I will also be willing, of course, to send it to Fiesole for storing on somewhere on their website. I want to start with something which I use frequently when I start this presentation to set the tone for the discussion. We're discussing how much we are surrounded by fantastic number in our life. So this is, according to the New York Times, the most important number you have never heard of, and it is the social cost of carbon in dollar per ton. Two numbers are offered here, $56 and $171, which are themselves the result of some kind of averages. The difference being due to the discount rate of money, which is, as everyone knows, a very parameter difficult to guess, also because this has been based on an analysis spanning 3 centuries into the future, considering the impact of climate on the economy. And this work has been done by very serious scholars, very serious people, and this work also has a political function, feeds into many policy process linked to various negotiations for climate change. In my opinion, and in the opinion of a few people in some of the community I happen to work with, this is pure madness. We cannot predict the economy 3 centuries in the future. Many years ago, in 2010, I was under the illusion or the delusion that I could demonstrate mathematically how crazy this work was by showing that if you reverse engineering one of these models for the damage of climate change on the economy, you end up with a distribution of error that is so large, that you cannot say anything. You cannot say, that is urgent or non-urgent to invest on offsetting climate change, because this was a big dispute between Nordhaus and Stern, two scholars very much involved in this kind of evaluation. Nicholas Stern was a Nobel Prize, and Wilhelm Nordhaus got the Holberger Prize, so they're really very well-known scholars. But their discussion was, in our opinion, futile, because really they could not get a handle on those numbers. This number was clearly fantastic, so neither of them was, in our opinion, right. So let's now, having done this introduction to vent my frustration at the predominance of those fantastic numbers in our blogosphere, let's come to the book. The book on the politics of modeling. Maybe the best things to read is the foreword of Wendy Espeland and the preface of Dan Sarewitz, which are really almost chapter in their own. They are not just a small text, but contains critical insight in the work of mathematical modeling. Then we have, the book has an introduction by the editor, so Monica and I, and Philip Stark, who is a statistician at Berkeley, has a very provocative article entitled "Pay Attention to the Model Behind the Curtain." Then we have the rules. I will go back to the rules in a moment, but those are rules which were thought of in a manifesto we published in 2020 in Nature. So these rules are for a number of gentlemen you see here: Arnold Puy at Birmingham University, Borgonovo is University Bocconi, and the Stirling Sussex University, and Wolfgang Drechsler is a Technological Institute in Tallinn. Then we have some application. We have other authors, Samuele Lopiano in Reading, Marta Cook-Cernesca is in Gdansk Polytechnic, Paolo Vineis is Imperial College, and Xing Tu, I think, is now in University of Sussex, moving from Edinburgh. And then some of these chapters are open for, unfortunately, the book is not open. We didn't have the money to make the full book open, but 3 chapters are open, one from Philip Stark, one from Arnold Puy, and one on sensitivity auditing by Lopiano, Razi. Samuel, you already mentioned Razi is from the Sharif University in in Iran. Best of luck to Razi for the election tomorrow. And then we have some papers which are relatively close to the chapter, which you can read in the open literature from, access from your library. The one from Andy Stirling is close to the unknown, Mind the Unknown chapter, and the one from Ting Su is close to the example of COVID and rulemaking using mathematical modeling. Also, the epilogue from Monica and I was published in a different form, of course, much expanded as in a journal article. And maybe I will also focus a bit on this one in my presentation. We had a lot of review. This was very good. One in Science, another on the old glorious Minerva journal. But in total, we had 4 academic review. And believe it or not, we also have a page on Wikipedia, which I encourage everyone to work on, because I think should be one of the duty of the academical people to contribute meaningful input to Wikipedia. So this is where the rule comes from. A manifesto we wrote in 2020. This was really a very lucky occasion. The COVID brought mathematical modeling to such a level of evidence that Nature accepted a paper critical of the way mathematical modeling was being used during the pandemic. Of course, the best thing of the paper was the illustration by David Parkins, which is I like very much always when I see his drawing on Nature. But the goal of this book was, in a sense, duplicate or extend what was being done in other families of quantification. And we wanted to bring to light the politics of numbers, and in particular, the politics of mathematical modeling numbers, okay? Trying to make a case. Of course, as you know, those of you who have done some sociology know that the numbers are not neutral, but they are used precisely because they bring with themselves an appearance of neutrality, which is very useful and very functional to offer legitimacy to those who produce those numbers. And they are also performative in the sense that they influence how things are then seen or done without appearing to be performative. So this is really what has been called the seduction of numbers, by Sally Engle-Mary recently. But this book of Porter, which you can find also in the web, is very good. Otherwise, I give you another article from Theodore Porter, who is one of the fathers of the sociology of quantification. So I mentioned sociology of quantification, but I would like to stress, as Gaby mentioned, that numbers can be visible or invisible. I would like to convince you that scholars of sociology of quantification tend to discuss in the same box both the visible number of statistics, GDP or employment rate, and mathematical modeling, infection rate, number of deaths from COVID, and the numbers that you don't see. For example, the number whereby you are denied a mortgage by the bank because the bank is using an algorithm, an artificial intelligence-based algorithm, to decide that you are or are not eligible for a mortgage. So these numbers, in a sense, come together, okay? Come together because it's very difficult to distinguish them. You use modeling to do statistics and vice versa. Artificial intelligence, there is a lot of modeling into it. Machine learning, what is machine learning if not, a very intricate multi-steps exercise in modeling? So it's difficult to even a ranking, a stupid ranking has a lot of modeling inside to decide how you rank the variables, how you weight them, how you aggregate them, and so on and so forth. And this is what makes those numbers, in a sense, belonging to the same family. Now, I want to make a small digression to see that this pervasive presence of numbers is not without consequence also for policy, because quite a number of different people coming from different traditions have sounded alarm, saying that this regime of numerification diminish the democratic agency of the citizen and lead to a form of a-democracy, which we a-democracy being something which sounds like democracy, but it's not a democracy because citizens have no agency. The books I present here, which are only a sample from a much wider possible set of books, are from one jurist, Supio, data scientist Katie O'Neill, a philosopher, Byung-Chul Han, Shoshana Zuboff is an economist, and the last one I read from Dan McQuilling is a science and technology scholar, in a sense, an STS scholar, but he was a physicist to start with. And for some people, like for instance, for Slavoj Zizevich, one consequence of this a-democracy is that people end up into identity politics. So the story is that if you take away from me the possibility to act as a subject of policy in the usual sense of the term, dividing between left, center, and right. So if you decrease this kind of political agency, what is left is identity politics, my sex, my religion, my nationality, the color of my skin, and the like. And I think the reason why I made this digression is that this kind of stuff is also among the things which interest the European University Institute cluster, for which Gaby is very much interested. You see the cluster here, the thematic priority. So democratic accountability, democratic life is also an important themes. We argue in the book that mathematical modeling live in a state of exception, no? From Schmidt, you know, state of exception, like if they are some kind of king, some kind of authoritarian character. Why do they have this state of exception? Well, I think that mathematical modeling has a unique repertoire of methods, even more than statistics. It has a lot of epistemic authority, which come from being mathematical. So mathematics is epistemically very authoritative. So authoritative that for many philosophers, mathematics is a language of God. You remember Galileo, no? The language of God. And those who want to demonstrate that mathematics is not the language of God, but is something which men create with their action, like the cognitive psychologists, George Lakoff and Nunes, you know, it's not easy. I mean, this book, which I show on the right, where mathematics come from, is really an attempt to show that mathematics is, in a sense, not the language of God. But this is an unfinished business. And by the way, I should also say that calling mathematical modeling mathematical is a bit of distortion, because many things enter into a mathematical model besides mathematics, but we will say more about that. For some people, modeling is not really a science, but more of an art, for Foster Morrison, or a craft for Robert Rosen, a relational ecologist. No? Robert Rosen says that if I look at a natural system and a formal system, both systems have their own internal causality, but no causality goes from left to right. Going from left to right to encode is left to the craftsmanship of the modeler. Okay, this is an important subject, but we leave it there for the moment, and those who are interested can read the book of Robert Rosen. So mathematical modeling, in a sense, fly under the radar of sociology, because sociologists are much more involved, at least as far as I'm reading, with other forms of quantification. Maybe the only form of mathematical modeling which sociologists have studied to a certain extent is cost-benefit analysis, which is maybe not even so much mathematical modeling. An exception to this is the book of Morrison and Morgan, Model as Mediators, which is a very interesting and deep book, not easy to read, because the people who wrote this book know very well the sociology, but they also know the subject matters of the models which are described in the book. And this is perhaps the reason why there is not so much sociology of mathematical modeling. It's simply so difficult to be cognizant in both things, no? This is an article where Arnold and I discuss how mathematical modeling can escape the sociology of quantification, and how the two fields could have a better dialogue, no? Okay. There is, in mathematical modeling, as in statistics, a need for equality which has a double dimension, technical and normative. In a sense, this comes from statistics/economics, because Robert Saleh, who writes in this book, which you can find open access on the web, Robert Saleh borrows this from Amartya Sen. Amartya Sen, discussing the quantification and discussing how the quantification needs a normative dimension, make the example of the capability approach. No, it's not enough for two people to have the same amount of good, because they may have different starting positions. So the amount of good should be such that each of them can reach a certain objective or their own objective, not simply receiving the same amount of good. This is an example of how fairness can enter into a quantification. Mathematical modeling are extremely malleable, no? Because in statistics, you have somehow to cheat with the data to achieve some kind of desired inference. But in mathematical modeling is even easier. Saleh talks about the bad statistics as the reversal of the statistical pyramid, governance-driven quantification. In my jargon, in the jargon of impact assessment, you distinguish between evidence-based policy, which correspond to good statistical work, the one done by official statistician in creating good indicators, to policy-based evidence, which is when you do the indicators just because you want to prove that a given policy is effective or needed. Another reason that models are so difficult, are so exceptional, is that they cannot be falsified. You cannot prove that a model is wrong because normally the model is co-created with its own data, and so it's difficult to use the data to disprove a model. Some authors have spoken of an incestuous relation between model and data, which is especially true when models are too large. So when models, for this reason, it's easier to use model to disprove something than it is to use model to prove something. Okay, because models are not physical law, whereby you simply compare the theory with the data, and if the data don't match the theory, in principle, but not always, you can say that you discard the theory. But models are a construction which include a lot of assumption, presupposition, secondary hypothesis, choice of resolution, algorithms, and so on and so forth. So when they are wrong, what was the problem? The input data, the model, any or all parts of this could be wrong. So it is really difficult to to say that a model is wrong in a certain sense, you know? And this is a bit like the Duhem-Quine critique in sociology, you know, that you cannot discard an hypothesis with some evidence, because the hypotheses come with many other secondary hypotheses. So also in this case, it's very difficult to distinguish what went wrong. And then but on the other hand, models are very successful, very much needed. They are fantastic in how they can operate between mediator between a theory and reality. Now, many scholars have said that the modeling is one of the most important activity you can do if you are in a science profession. So really, also this makes model pervasive, you know. Some scholars talk about invisible science. I think it's Stephen Shapin, but you could also talk about invisible models, those models which we don't see, but which make our life in a sense easier and create a few problems. Also, model can be thought of as an image, a snapshot of how we perceive the world. Now imagine an archaeologist of the future will study our mathematical modeling, and based on this, understand how we how perceive the world. And at the same time, models can be used within communities to deliberate, to analyze an issue. So model can also be part of some kind of participatory process in a context of, for example, an extended peer community. This is a concept which comes from post-normal science. And then one of the, now there are a number of consequences descending from the state of exception. One is there is an incredible asymmetry between developers and users. But I would contend that the asymmetry is larger for mathematical model than it is for statistical indicators, okay? Because, okay, but this is based on my own experience. I don't know if you agree on that. And then there is also that the fact that model can lend themselves to ritual use. This is a very nice example from Kenneth Arrow, who was asked to produce during the Second World War. He was asked to produce a prediction of climate 2 weeks ahead, and he said, "But this is horrible. Doesn't serve anything. It's not, this prediction is not good." But he was told to keep doing this because it was needed for planning purposes. No, so you see, there is this kind of ritualistic use of model, which is not unknown in statistics. No, if you have, if you know Gigerenzer has written a lot on the ritual use of the p-test, for example. No, people use statistical inference ritualistically without understanding really the implication of the use of those inference method. Okay, so there is the story of transscience. No, I have here an example of a question which sounds scientific, but which in principle you should not be able to answer scientifically. How many people will sit in an autonomous car by 2050? How will the spread of malaria change if global temperature increase of 1.5 degrees centigrade? And what will be the cost of CO2 average over the next 3 centuries? Clearly, some people is very active at putting number on these 3 things, but this is what precisely Weinberg would have called trans science. And there is also, of course, because as one of the consequences of the state of exception, that the possibility that model could damage. So, and this can be in medical research, in higher education, in finance, in the governance of science. This is a book from Mittelman on higher education, the impact of higher education, ranking on the higher education. The book of Richard Harris is on medical research, and the book of Wendy Espeland is also on the ranking of higher education. But there are many, many other examples which you can find. Well, this one which I like very much because I worked on it is one on the OECD PISA test, which is very useful for educationalists. But when we reflect on, was PISA useful or was it damaging education? Probably, you know, the on balance, it was damaging. Also because there is always one more method in quantification which will be good, the gold standard. No, then there is always one new method to add to the palette which will solve all problems, like randomized control trial or sophisticated statistical econometric techniques. But again, all these methods suffer from what is today being called analytic flexibility. No, this is very recent. Now, very recently, people have realized that econometric analysis are flexible, meaning by this that changing assumption, the result can change a lot. This is a field where I'm also working at present. But many of these things are also discussed in the article of Schoons and Stirling on this book, which is also open access. You can read it online. Okay, and okay, I mentioned the rules. Okay, these are the rules which were in the manifesto. But if you want to see more example of good or bad use of model, you can go back to the manifesto and also to the supplementary material where we had to compile, no, good and negative example of mathematical modeling used properly, and mathematical modeling possibly being used improperly, no. One consequence of this state of exception is that we see one-to-one map of the empire. I hope that in the audience today there will be many readers of Jorge Luis Borges, this fantastic Argentinian writer who writes about a map which was so big as to cover as the entire empire, because it was a one-to-one map, no? And we are now discussing really in these days to do a similar map, a one-to-one map of the planet, including its economy. This is called digital twin of the Earth. In Europe, this is called Destination Earth project. Of course, as you can understand, I find this project not terribly useful. For is really a big case of hubris. If you don't believe, look at what is written on Euronews about this project. A complex computer model takes into account weather, climate, as well as our impact on the economy. Destined Air is a true game changer in our fight against climate change. Today, the future is literally at our fingertips. And here in this image, you see how the planet is perceived, you know, into the mind of those policymakers. Really, you know, there is a switch, we can move the switch. And, I mean, this is really, when you think of after, you know, a couple of centuries of ecology, I guess all the ecology in the room will be now crying. Anyhow, so clearly this kind of mathematical modeling is also functional to make promises which are empty, no? There are a lot of promises going around of a circular economy. There are many things said about energy transition which don't correspond to the reality as simply promises. And if you look at this with the lenses of bioeconomy, of relational ecology, you can find it and you can debunk those narratives. This is a paper, but you know, if you read the book of Václav Smil, you will see how many of these promises are really not based on actual numbers, no? So in this article, we talk of the economy of techno-scientific promises, no? Promises of why those are empty promises? Because those are promises that we will keep doing everything as we do today in terms of consumption, no? Simply because technology will offer us new way to do what we already do. And this is what clearly will not work, because technology will only be able to increase our consumption. We argue, you may disagree, but not easily decrease our consumption, because decreasing consumption implies politicians doing something as opposed to relying on the promises of technology. Then models can act as chameleon. We have seen this during COVID, no? During COVID, we used a model of Ferguson of the Imperial College, which was a study model, you know, agent-based model, a big model. And this model was used to make prediction for policy. Probably this was not the right model for doing prediction on policy. No, a much simpler SIR model would have been equally effective. But you know, they can be chameleon, because they can say, "Oh yes, but we are only study models." No, when when someone objects, "But why are you using this model for policy?" "Oh yes, you are right. We are only study model. We need more research and more data." We have seen this several times, no? About the model hubris, this is something we discuss in several papers beside the book and in the manifesto. When you build a model, you normally make the model better because you increase its descriptive capacity, but as you add modules, parameters, equations, all this needs more data, and each datum comes with some error, so that the error will start increasing again, and in the end, the model will be, you know, totally unreliable simply because the error is too large. So the model is complete, contains many things, but the result is too uncertain to be of any practical use. So there is an optimal point of complexity for a given level of evidence, no? What are the solutions to this? Well, I think we can take the example from the statistician again, because they have, for example, a current especially active in France called stat activist, which fight a number with a number, or under the slogan, a better number is possible. We can do in mathematical modeling the same thing using sensitivity analysis, sensitivity auditing, which is an extension of sensitivity analysis, or modeling of the modeling process, which today is has been rediscovered under the name of multiverse analysis, which is a more catchy name, I admit. But with this kind of technique, you can deconstruct and reconstruct the quantification, okay? You can deconstruct a bad number and possibly construct a better number. And to do this, you must retrace what was assumed and then check, for example, the level of complexity, and then, you know, do a number of this kind of analysis, no? One thing you can do is not quantify. You know, some numbers are really funny in a sense, no? When I was mentioning the bad numbers of finance, there is, please read this very short piece. This is a funny piece of Theodore Porter about funny numbers, on how these numbers look very serious on the surface, but as soon as you open the hood of quantification, you see that they are totally ludicrous. Which is the point made by Porter in his article, in any case. And then we believe more time can be spent discussing models than constructing them, in the sense that, for instance, many years ago, we had a big discussion on the iPad model, no? That the impact on the planet is proportional to population times affluent times technology. This is a very stupid model, a simple linear equation. But with this model, a good conversation could be had on the limit to growth. Okay, you may say this is an extreme example, but this gives you an idea of how you can discuss important policy dimension also based on a very simple mathematical modeling. And then people, so I mean, this is happening already, you know, society is now more alert to these things. And then what we want to achieve is a reciprocal domestication between models and society, you know. Here is an example. When there was COVID, many different policies were enacted in different parts of the world. And yet everyone was saying that they were following the science. No, but if everyone was following the science, then something was wrong with the science. So clearly science was not speaking perhaps with one voice. This is how people become, after COVID, generally more, in a certain sense, skeptical of expertise in general, but this is also another, this could be the subject of another seminar probably. In post-normal science, there has been a long discussion on this, especially in relation to risk analysis, no? The numbers of risk analysis are foggy, no? They should be defogged. And this is a discussion which is also very well practiced by the ecologists. No? If you read Langdon Winner, Mumford, or Ivan Illich, or Schumacher, all these ecologists have written similar things. Now that those numbers of risk analysis, cost-benefit analysis, you know, should be looked at with a certain skepticism. Here is also, again, of risk analysis and cost-benefit analysis, and to use more the lenses we suggested in this process following Georgios Korogan, and then approaches originated in the context of science, such as sensitivity developed already in the 90s, quantitative storytelling, and other approaches of this kind. And we do this because if you linearize quantification, you generate invisibility. In order, there could be an invisibility of qualities, well, if you use Ricardo's theorem, but if you don't use bioeconomics, you will not carefully apprise the existence of something called entropy and the fact that natural resources are not infinitely substitutable. If you use post-normal science, you will not be blind to the contamination between facts and value, which is obfuscated by the purported neutrality of quantification. So I conclude to say, this is my last slide, that precisely, what was it, 40 years ago, this man, Brian Wynne, which is a very critical STS scholar, one of the best, debunked a very big assessment of the energy future done at IIASA, the agency in Vienna. This big report predicted that in 2030, so practically now, we shall be mostly using 3 sources of energy. Fast breeder reactors, which is not normal nuclear reactor. Those are nuclear reactors which generate more fuel than they consume and which are normally now only used for military purposes. We would use then centralized solar, meaning gross plant concentrating solar energy and not what we are having now. And third, synthetic fuel from coal. None of these 3 options did materialize. And if you look at the image on the left corner, a fast breeder reactor in the Netherlands is today an amusement park. And what I want to say is that this is a kind of, the report of IASA prescribed scientifically that this will be our energy future, the same way the proposer of digital twin tell us that digital twin of the planet are scientifically prescribed by our technology. I think I stayed in my 45 minutes, and there are extra references and maybe extra slides if you're interested at the bottom of this, which you can find. Thank you very much.
Great, thank you very much, Andrea, and thank you for also linking it always to the academic debate, which is very interesting, you know, to see where the schools touch upon each other and potentially not speak to each other. We actually open immediately the floor for Q&A. Raise your hand, please, and ask your question if you want to. I'm monitoring that, but if I overlook something, just open your mic and ask. Andrea, all of what you said culminates for me in 3 types of questions. And one question, because Raffaele and I talked about that over the coffee break this morning. Maybe this question before, as you said, this asymmetry between mathematical modeling and statistics, the use, and the question of transparency of it. And you said that's more or less the same. And we actually said, no, mathematical modeling is still a bit less tangible for policymakers potentially, because a number or an index gives you an impression of materiality and is a bit more tangible. It would be great if you could develop this a bit more, why you say it's actually the same in terms of the asymmetry between users and producers of the modeling. The 3 points that I wanted to make is when you say that, and you wonderfully with the last slide brought in what I wanted to ask, the relation between forecasting and foresight for policymaking, because part of what he does is indeed foresight, right, with the models that he develops that are based, however, on his forecast work, I assume, and the forecast work. So if we think once of modeling, future-oriented modeling, as an instrument of politics, where do you see the limits of that? And where should developing ideas for the future become more democratic? Where can we have this democratic perspective on the future? And where do we need to democratize thinking of these models, like a fast breeder reactor, in a more democratic way to make these ideas fly for the future and not just remain in a very limited group of actors prominent? In line with that, I'm wondering if modeling can actually always only extend reality rather than be path-breaking by the very nature of it. So if we're too much engaging in integrating mathematical modeling as a policy tool and a mode of governance, will we foster a path-dependent development rather than a path-breaking because of the methodology of modeling? And finally, what is the role of the scientists in all of that?
Then.
What is the role of scientists?
I counted 5 questions. Then now
no, it was under bullet points. What is the role of the scientists in that? You know, asymmetries, relevance, and for literacy questions, how to convey the limits, the limitation of the methods, how to add disclaimers, methodological ones, to make users of modeling understand the inbuilt limitations potentially, And I leave it there. Everyone else, please come in.
Yeah, thank you.
Thank you, Gaby.
Okay, I have 45 minutes, right?
3 hours.
No, okay. No, mathematics and statistics, you know, I say, I wish mathematics were like statistics. So it's two different things. Mathematical modeling can be as influential as statistics in policy. I stand by this, though you maybe disagree because you, Gaby, come more from the school of official statistics. So you know more of this other side, but I know more on the on the mathematical side. So I believe these two are comparable in their effect on policy. They are really both quite powerful. But unfortunately, statistics is much more, in a sense, transparent, or at least is more studied by sociologists and has more reflexive in itself than it is mathematical modeling. This was all what I tried to see. When you talk about forecast versus foresight, of course, what's wrong with foresight? Nothing is wrong for foresight. The point is, like, again, this story of the chameleon, no? I do foresight, but then in the policy brief coming from the foresight report, one read that this is scientific prescription. So what was a foresight becomes a prediction which we have to comply with because science and spoken. So again, there is this ductility, no, which I think should be resisted. Then what we should do to democratize all this, I don't have a solution there, Gaby, because democratizing science is a very, very hard task because those who have power can normally also, in a sense, hijack this process whereby science is democratized. So a lot of vigilance is needed. No? In the case of the stat activists, for example, they made important alliances with institutions, like, for instance, in France, the INSEE, the statistical office itself, and the media, the journal Le Monde. Without those powerful allies, the statistician of the statistical movement could not really fight the fight they fought. So I don't believe there is an easy way other than for, you know, people like us try to suggest strategy of social awareness or social resistance. But no, I agree with you that the impact of all this on democracy is really something but probably, you know, this would be the subject of a new seminar if we were to discuss in what level quantification could be used as a tool to democratize expertise instead of deprive people of political agency.
Now I go with the mic open. Great. Thank you very much, Andrea, for that. What is interesting, I think, to look into is how statisticians, modelers, data scientists working on models could or can interact with policy in order to make the models more understandable to policymakers. Do you see anything along these lines happening? So what we see in the International Statistical Institute, for example, are until 25 with the new activity program, is a boost of activities to interlink more with society, to bring statistical literacy into society, to make basically statistics an everyday life experience so that people can understand better how politics are informed by numbers. Is there a role to play for mathematical modelers as well, or is that too complex? Because as you rightly so said, these the distance, still language of God in some people's minds of mathematics from policymaking present day. What do you think of that?
No, I fundamentally disagree. I don't believe modelers can be relied to make by themselves the effort to become transparent, precisely because, as I tried to explain, part of their epistemic authority derives from being non-transparent. And so they will not relish this voluntarily, because this is what provide their, in a sense, you know, their funding and their living. So I believe only a reaction of societal vigilance, you know, can keep modelers straight, you know, can force modelers to open the black box of their tools, precisely as the people in who do ethics of algorithms do when they do hackathons, and they open the algorithm to reveal to the society the preconcept, no, the bias, even racist bias hidden inside the algorithm. So I don't think this will be done. Exactly how the developer of algorithm will not do this, so the modeler will not do this themselves. Someone else has to push in this direction and force them to do this.